Hello and good afternoon. This video tutorial is going to be on OSPFv3 and specifically setting up authentication and encryption between OSPFv3 neighbors. And so when we say OSPFv3, we're talking about IPv6, which means we're also going to be talking about IPSec. So let's go ahead and jump in. As you can see, the topology that we're going to be using is the topology over here to the left. And these are actual physical 1841 Cisco routers with the iOS versions right over here to the left-hand side and then to the right-hand side on this guy. So we've got two that are running 15.3 code, and we have one running 12.4.28T8. And this is going to be interesting because there's a very annoying and well-known bug that's out there with the 12.4 version of code. And as you can see, we've even got the bug search tool up here. And so we'll talk about that in a second here with respect to setting up OSPF authentication and encryption between the routers running OSPFv3. So the OSPF configuration has already been done. So where do we start? So with OSPFv3, when you're using IPv6, there are two basic ways to set up the authentication and the encryption, very similar to when you're doing OSPFv2 with IPv4. You can do it under the interface, and you can also do it under the area configuration. So let's take a look here on router 4. We'll do a show run section OSPF. And so there is the OSPF section right now. It's just simply these commands down here, the IPv6 router OSPF4. So the process ID I'm using on each of the routers corresponds to the router number. So OSPF process ID 4 on router 4, 5 on router 5, etc. For the router ID, it's the same thing, 4.4.4.4. So we're going to mix and match the authentication types, because if you do your setup under the router config area for OSPF, and then you do it on an interface, the interface configuration will override or take precedence when you're dealing with the OSPFv3 authentication using IPSec. All right, so let's go ahead and jump in. We're going to set up the authentication and encryption, and there's a subtle difference here, and we'll see when we're writing the commands out to turn it on the interfaces, where you can do just authentication, right, using an MD5 hash. You can do just authentication using the encryption command, but setting the ESP to null, right, the Encapsulating Security Payload. You can set that to null, and so then that's just doing authentication. Or you can do IPv6 OSPF encryption and use triple DES. I think AES is an option as well, we'll see here, with ESP, the Encapsulating Security Payload, and it'll give you authentication and encryption, or I should say it'll give you encryption, right? It's the differences between ESP and AH. We'll talk about those here shortly, but let's go ahead and jump in right now. So if I were to do a show IP interface brief, we should confirm that fast Ethernet 00 is going to be the Ethernet interface that we're interested in taking a look at here, because this is where we have do show run interface FA00. This is where we have OSPF configured, right? So if I were to do a do show IPv6 OSPF interface, we should see interface fast Ethernet 00 here at the end. So here is our information for that interface. You can see it's adjacent with neighbor 6.6.6.6. And again, this is the router ID for router 6. It's still, even though we're doing only IPv6 here, there is no dual stack in play here. So it's pure IPv6. Even though we're doing IPv6 or OSPFv3, we still use a 32-bit router ID, right? So it's not a 128-bit router ID. So we've got some other information here. It shows us the link local address on this router for fast Ethernet 00. It gives us the interface ID, area 0, what the process ID is, our router ID. What's the network type, right? Is it point-to-point? Is it broadcast? Is it point-to-multipoint? So here it's a broadcast with a cost of 1. So there's our OSPF cost is 1. And the hello and dead timers, right? You can see those as well. So we are the backup designated router, and router 6 is actually the DR. And we've got our local addresses here, right? And OSPFv3 is going to be using your link local addresses when it's establishing its adjacency. All right. So we're good to go there. So let's take a look at some of the commands that you can do, or that you can run here, and how we can set it up. So if we wanted to do authentication only, I could say IP OSPF authentication, and so I could use null, which means no authentication, but we're already using no authentication right now, so that's not what we want. So I want to choose IPSec, and there's a lot of talk about how IPSec is sort of built in to the IPv6 protocol, right? And so this is definitely one way that we can take advantage of that. All right, so next up we see the SPI, and the SPI stands for the Security Parameters Index. So the key thing to remember about the Security Parameters Index, if you think of it, if I do a question mark here after SPI, you can see that it has a value. So you can think of it as being sort of analogous to the key ID, where before we would, with the OSPFv2, with IPv4, we would want those key IDs to match, right, in order to set up that security association and to be able to sort of exchange the keys. So the SPI, or the Security Parameters Index, is analogous to the keying with OSPFv2 with IPv4, because the SPI has to match on both sides in order for the authentication or the authentication and encryption to work as advertised, right? If we don't match them, and I'll intentionally not match them in this first instance here, you'll see what happens. So that's what the Security Parameters Index is. It's a 32-bit value, and you can see it's anywhere from 256 up to 4.2 billion, and it has to match on both sides of the communication, right? Okay, so we'll go ahead and choose, we'll just say that this is going to be 6464, because it's going between routers 6 and 4. So if we do a question mark out here, now we get to choose the type of authentication we would like to use, either MD5 or SHA. And as I've spoken about previously in some other videos, Cisco recommends not to use MD5, because MD5 is considered a legacy authentication. So what we would rather use would be SHA-1. Okay, and then here's where we put in a hex string, and you can see where it says 0 if it's not encrypted, 7 if the key is encrypted, or we put the hex, just the regular hex string in, and it has to be 40 characters. It cannot be shorter than that. So if I were to type in those numbers right there, which would all be interpreted as hex, it's going to come back and tell you OSPFv3 authentication key, it must be 40 hexadecimal digits. So now it's probably not, I'm trying to think of the right way to say it, it's probably not, I don't want to say a good idea, but it's not good time management if you're sitting around trying to think about what would be a really cool 40-digit hex key. Obviously, randomness is a good thing, especially when it comes to hashes. So, and I want to give full credit here, a gentleman by the name of Jeremy Stretch, and you can read his blogs at packetlife.net, posted something up about randomly generating a 40-bit key, and that you can do that. And I'm looking for my Linux VM, which may be, yeah, it's right. Okay, it's right there in the background, which is actually already running. So we need a 40-bit random string of characters. And if I cat my .bash_profile, I just threw this in here on this VM, you can see that this command right here, and again, I want to thank Jeremy for posting this, will give you a random 40, I shouldn't say bit, 40 hex character string, 40 hex string, 40 character hex string. All right, so if I were to type in keygen 4096 and hit enter, and did I type that in wrong? Keygen, oh, I did. Got the last two numbers wrong. So 4096, it's just a quick function, and right there is my random hex string. I apologize, I was saying bits earlier, but random hex string. These are hex characters, right? So I'm going to paste that in, and we're going to use that. And that is not what I wanted. It looks like it actually had, because I had that selected earlier. So let's go ahead and start that again. So we'll say IPv6, OSPF, authentication, we're going to say IPSec, and the SPI will be 6464, and we're going to use SHA, and now we're back to that random string. And let's make sure that that is not selected. And I may be having problems cutting and pasting between the VM here. The VM is going to give me some issues. So let's see, I'll say copy, and if it doesn't work here, we'll have to go to a backup method. Yeah, you can see where it's actually taking out of the buffer from within Secure CRT as opposed to the string that I'm trying to connect to it. So we'll come over here. I know out of the browser we're not going to have that same problem. So I'm going to simply grab this, and this is out of the Cisco OSPF config guide for 15 MNT, or it should be 15 MNT. Yep, so for 15 MNT, and it talks a little bit about OSPFv3, IPSec, and ESP encryption authentication. So you'll notice that it talks about the authentication header here, and that you use that with the IPv6 OSPF authentication command. However, it says to use ESP, the ESP header, you must enable IPv6 OSPF encryption. Now, it can be applied alone or in combination with the authentication header. When ESP is used, both encryption and authentication are provided. So the question then is, why would I use the authentication header? And to be honest with you, AH is, I don't want to say deprecated, but it's definitely not used a lot anymore, and there are a couple reasons for that. So what I first want to do is get this string in here. So let's put this string in. So IPv6, OSPF, authentication, we're going to say IPSec, SPI, 6464, and now we get to the SHA-1, and now I'm going to paste that string in here. So there is our 40 hex digits, and if I do a question mark at the end, you can see that's it. So I'm going to hit enter now. So now this has been enabled on router 4. However, on the other end of the link, I have not enabled authentication. So on router 6, we have not enabled authentication. So if I do a show IPv6, OSPF neighbor, you can see that we're still up, right? We're still full with router 4, but let's see if that changes here. And while we're waiting to see if we get anything to change there, let's talk about the authentication header and the encapsulating security payload header real quickly. So if I had two routers like I have in this instance here, and let's say we've got here, I've got router 4, and then over here I've got router 6, and we've got a connection between these two routers. When I use AH, right, or the authentication header, and you should know already that with the authentication header, NAT and AH do not get along very well, and we're going to see why here in just a second. So on router 4, when the traffic leaves to go over, we've got your typical, whoops, layers 5 through 7, right? And then you've got your layer 4 or the TCP, if it's TCP. Then you've got your layer 3, which in our case is going to be IPv6. And what happens is, with the authentication header, we then tag on or encapsulate that with the authentication header, right, for authentication purposes, and then we put an IP, another IP header here. Now, what happens is that there's an integrity check that takes place here, specifically looking at the new IP header. So we'll put in here integrity check. So there's an integrity check that takes place here, right? And so if you're doing NAT, this integrity check, we're going to run into issues because that IP address on the outside, that IP address which is located on the outside, could change. And so obviously the integrity check that takes place if NAT is in effect is going to impact things, right? So if we were using ESP, what would happen between router 4 and router 6 is that, and I'll draw it a little longer here. So you still have your layer 5 through layer 7. You've got your layer 4 here, which could be TCP, and you've got your layer 3, which in our case is going to be IPv6. But then you have the encapsulating security payload, right? And then you have what we refer to as just simply the new, the new IP information, right? Now, something to keep in mind is that the authentication header setup that we had up here earlier, and this is going to be all one big encapsulated payload there. So again, we have an integrity check here on the IP, right? And none of this information behind me, right, the payload here, what we're trying to get across to the other side, the payload is not encrypted, right? So it's not encrypted. None of the payload is encrypted here, but we have this authentication header and it does an integrity check, and then the integrity check on the AP, which is why we say it's providing authentication, not encryption. However, with ESP, the encapsulating security payload, you've got encryption, right? Now, obviously, the IP here is not encrypted because it has to be interpreted on the other side. However, from here back, the payload is encrypted. And this is very important, right? Because we want to make sure that we are protecting this payload. And so per the Cisco doc with ESP, we are getting authentication and encryption. So there's really no reason for us to use AH, especially if NAT is in the equation, right? So if you're doing any kind of a NAT, you're going to end up having issues if you're going to use authentication header instead of the encapsulating security payload. All right, so let's come back over here and take a look. So we've set up authentication, but nothing's happened. We have not lost any of our neighbor adjacencies. Well, let's do a quick check here. IPv6, OSPF neighbor, right? So it's in the init state though, as you can see here, and it's showing as DR other. So let's come over to router 6, and sure enough, the Cisco iOS has been kind enough to dovetail off of the authentication header encapsulating security payload header conversation, and now it's gone down. So if I do a show IPv6 OSPF neighbor, what do we see? We only see neighbor 5, right, or router 5. Come back over here, same thing, right? On router 4, it shows it in the init state, right? So we can't get out of the init state. So if I were to do debug IPv6 OSPF adjacency and an OSPF events, might we see something, right? It's possible that we may see something. So remember, if I do show run and what interface, do show run interface FA00, all right, so there is our string, right? And this is turning on authentication. So remember, this is not encrypting anything. This is simply providing authentication between router 4 and router 6. So let's go on to the other side, and we're going to intentionally misconfigure the SPI, the security parameter index, right? So we're going to intentionally misconfigure that to see what happens. So we'll go global config interface FA01, and I'm going to go ahead and type or paste in that authentication message. Now that string, that 40-bit hex string, right, we want to make sure that that is also the same. So I'm going to change it from 6464 to 4646 and hit enter. And let's see. So you get a nice message here, right? Crypto 6, ISACAMP on off, ISACAMP is on, right? And one of the nice things about the OSPFv3 authentication is that you don't have to go in and do a separate IPSec config where you've got the transform set that you're setting up. You literally only have to do it at the interface level on either side, or if you want all interfaces on the same router to be using the same configuration and setup, you could do it from the OSPFv3 router configuration section. So, all right, we've entered this in. Let's come over here to router 4 now, and let's see what's happening. So router 4 now has finally declared router 6 to be dead. The state is down, and it's gone from init to down. Router 4 is now going through the DR/BDR election process, and it's electing itself as the DR. So you'll notice with the different security parameter index, right, that SPI value, if it doesn't match, do show IPv6 OSPF neighbor, right, it's not going to establish an adjacency with the other neighbor. So let's resolve that. Let me go ahead and come over here to router 6. We'll pull that command back up, and I'll say Control A. We're going to say no IPv6, and then I'm going to drop back, and I'm a little disappointed it did that. I think it's Control R. There we go. Control R to redraw my line. All right, so let's fly back here, and now let's make this right. So we're going to make this 6464 and hit enter, and let's come over to router 4 and see what happens. So as soon as we hit that OSPFv3 IPv6 adjacency, we got a message that generated saying added 6.6.6.6 to the neighbor list. So if I do a do show IP OSPF, whoops, show IPv6 OSPF neighbors, right? It's in the init state, and it's been added to the neighbor database. We'll come back over here to router 6, and let's say do show IPv6 OSPF neighbor, but nothing yet between 4 and 6. So 6 hasn't, let me make sure, do show run int FA01. Let's make sure. Aha! So it did not take that command. So let's rerun that command. It doesn't look like it took it, and this is the command that we want here to match them up. So I'll say copy, and we'll paste that in over here. All right, so ISACAMP is on, and as you can see, neighbor 44 went from loading to full. And let's take a look over here on router 4, because we're doing some debugs over here. And you can see that it went through the DR/BDR election. The database descriptors have been sent back and forth and exchanged, and we've gone to a synchronized state of full. So again, that SPI, or that security parameter index, that 32-bit value needs to be the same. So again, do show run int FA00. So this is our security parameter index. Just think of it as a key, and that the key on both sides needs to match. Now, as we said before, what is this actually doing? This is really just providing authentication, right? It's not providing any encryption at all. So if we come back to our drawing, so this is kind of what we're getting right now, is just the authentication, where we have an integrity check that takes place here and investigates the IP, right, to make sure that these packets that are being received are legitimate and valid packets. And so that's the authentication piece. So what we want to do now is we're going to go ahead, we'll leave the authentication between 4 and 6 the way it is. But now what we're going to do is we're going to set it up with ESP, and you're going to see that we can do both authentication and encryption. And actually you can do it in a single command, one line, right? It's a very long line because it's going to have a 40 hex character string and then a 48 character hex string. And so let's take a look at that. So if I'm on router 6 and I want to go to interface FA00, do show run int FA00, and you can see we've got our link local and our IPv6 address defined. So now we're going to do IPv6, OSPF, and encryption. Whereas before, if I back up here, you can see I've got a couple of choices that I can make, but we're interested in encryption and authentication. So what we did first was we did the authentication, right? Now we're going to do the encryption, right? So we're going to enable encryption here. And it's going to be, and let me back up to show you the options. So it's IPSec or null. So null means that there's no IPSec encryption, but we already have no IPSec encryption. So we're going to say IPSec, use the question mark. Again, the security parameter index, same value. So for this one, we'll just say 6565. So it's between router 6 and 5. And so here's our choice, right? So if we're doing encryption, there is no choice for AH, right? The only choice here is the encapsulating security payload, or ESP, right? For our ESP encapsulation of the traffic going between the routers. So we'll say ESP. Now we have the encryption algorithm. We can choose triple DES, AES CBC, DES, or null. Now, right here, if I were to choose null, that would mean that we would have the authentication, but we're not going to have the encryption. However, we want the encryption, right? So we're going to say triple DES, which of those three is probably one of the stronger choices. And so here is where we now have another hex string that we need to add in, and this one's going to be 48 hex characters. I said bits before. So we're going to make it 48 hex characters. So I know that this is 40. So we'll grab this here. We'll come back over here, and I'm going to say paste, and then we'll add in the other 8. We're just going to make it FF. So there's the other 8 that we were missing. But we're not done yet, because remember, we can actually accomplish the authentication and the encryption in one command. So I'm going to do a question mark, and now we get down to the authentication hash, right? Are we going to do MD5 or SHA? So the first sort of half of the command, if you want to logically break it up, the first half of the command, we get the encryption component set up. The second half of the command, we're now going to set the authentication component up. So I'm going to say SHA-1 because I trust SHA-1 more than I do MD5. And then again, a 40 character hex string, and so we've already got that saved off. So we'll use that string there, and that is the entire command. So, and that is definitely a very long command. So if I do a do show run in FA00, so there's the command, and that's what it looks like, right? So we've defined encryption with IPSec, and we've also got the authentication defined as well. And so this is what the document, the Cisco document, is referring to when it says that with ESP we can get both. We can do the encryption and the authentication all with a single command. So let me copy this command, and now we're going to transition here over to router 5's FA00 interface. And so as you can see, it looks like the relationship, as soon as we applied that, the relationship has gone down. And actually, let me digress for a second here, and let's take a look. If you were to do, there's some commands that you can run that you want to keep in your, keep readily available. So show crypto, what are we doing? Crypto IPSec SA, right? So if I do a show crypto IPSec SA, it's going to show me the security associations that I have. So one of the things to remember is that when you're dealing with ESP and you're dealing with IPSec security associations, that so the IPSec security associations, those are unidirectional. And what that means is we're going to have one entry here. You'll see there's inbound and outbound, right? So inbound ESP security association, inbound authentication header security associations. So there's our security parameter index. We should recognize that, right? Because this is for the communication between router 4 and router 6. So you can see here, right, it's unidirectional. So we have an inbound entry, right, status is active, and then we have an outbound entry. And again, status is active. And so these two entries represent the unidirectional communication that we're receiving from router 4 and that we are sending to router 4 for this specific authentication, this AH, Authentication Header Security Association. And so now what's going to happen is we should also see an inbound Encapsulating Security Payload, ESP, Security Association, as well as an outbound, right, as soon as we complete the configuration work over here on router 5. So let me come over here to router 5, and we're going to go into global config mode, interface FA00, and I'm definitely going to paste that command. Oh, it looks like it still has the old information. So let's make sure I didn't mess up the interface. Do show run int FA00. All right, so it still looks good there. Let's come over here, whoops, router 6. And we're going to grab this command here. And you can see right now, do show IPv6 OSPF neighbor, right? My relationship, I only have a relationship with my neighbor router 4, because router 6, again, router 6 is already set up the encryption and authentication piece. We have not, so we're going to do that right now. All right, so there's the command, and I hit enter, and it looks like it did not like the length of that command. Let me walk this back here and make sure that we've got everything in there. All right, so everything appears to be in there, and it looks like it doesn't like it when it gets to the 6. And let's see if that's where the line it is. Let me see if I stretch this out, see if it makes it any different. And I might end up typing some of this out here, or all of it. All right, so there it is. Yeah, it doesn't like it. So we're going to go ahead, we'll type it in anyway. So we'll just say IPv6, OSPF, encryption, oops. And it actually dropped me out of, now I see why it's not taking it. The previous paste where the buffer was messed up dropped me back to global config mode. So let me go into the interface, paste in the proper information. This should work. All right, authentication key must be 40 hexadecimal digits. So now we're under the interface. This should work. And let's grab, oops, not router 4. I want to look at router 6. So copy, and it should take this. All right, there we go. Much better. So after our cutting and pasting challenges have been overcome, let's take a look at do show IPv6 OSPF neighbor. You can see that I still only have the relationship with the adjacency with router 4 at this point. And let's come over here to router 6 and do a show IPv6 OSPF neighbor, see what router 6 sees. So it shows it's in the init state with router 5. However, router 5 is not establishing an adjacency with router 6. So this could be a problem. And in fact, I actually already know that it is going to be a problem. We're going to take a look at what's going on here in just a second. So if I come over to router 4 to complete the connections, where we're going to go ahead and on the serial interface, let me slide this over here a little bit. On the serial interface for router 4, we're going to go ahead and set up ESP as well so that we have encryption and authentication. And I'm going to go ahead and go into interface serial 010. And we would use that same command. Right, we're going to use the same SPI between the two, and I would do the same thing on interface serial 010 over on router 5. So let's see, is the problem that it's an Ethernet interface? Aha! So now we do have an issue. Now this is another thing where the security parameter index needs to be unique on the router. So on router 4 I was able to use 6565 because I don't already have that. However, between routers 5 and 6, that's the SPI that I'm using. So let's change that. So we'll go ahead and make it uniform like it is with the other ones, and we're just going to say 5454. So I'd have to come back over here to router 4 and rerun the same command. And we'll change this to 5454. Again, think of it like a key that has to match. But that is not going to fix our problem, right? So if I do a do show IPv6, OSPF neighbor, I only have, actually I have no relationships right now. But what about on router 6? Show IPv6, OSPF neighbor. Have a relationship with router 4, right? And 4 should have only a relationship. And you can see that as soon as we applied the OSPFv3 IPSec authentication and encryption between 4 and 5 and 5 and 6, 5 has completely dropped off the map. Now it was interesting when I was tinkering with this a few months ago that I stumbled upon this issue here where you can see that I'm using iOS 15.3.3 on routers 4 and 6, and 4 and 6 aren't having any issues. However, iOS 12.4.24 is obviously different than 15.3, so I was wondering, does it have something to do with the iOS? And sure enough, there is actually a bug ID, CSC TC72699, that with OSPFv3, neighbor cannot be established when using IPSec authentication. Right? In fact, we're using the encryption. It simply can't be established. And the symptom was talking about a 2811. Well, these are 1841s, and the code is probably not that much different between the 2811 and an 1841, and they also show 2851. So it's interesting. It says the symptoms observed with 12.4.24 and when I saw that, I was like, you've got to be kidding me, because I'm running 12.4.24 What's interesting is here under known fixes is this right here. 12.4.24 is listed as a known fixed release. However, you can clearly see that router 5 has no adjacencies, and the configurations are correct on router 5 between 5 and 4 and 5 and 6, so that's not our problem, right? And you can see that the adjacency relationships have gone down on both sides. And so what's interesting is here's the workaround. So right now the Crypton engine onboard is set to 0, which means do it in hardware. So we're going to change that setting. So we're going to set the no crypto engine onboard 0, and it's actually going to flip it to do it in software. So no, and I think we need to get in global config. So we'll say no crypto engine, and as you can see, software, you can choose software, but we want onboard and the crypto engine 0. So as soon as I enter that command, you can see that it tells me switching to software crypto engine, right? And the crypto engine onboard 0, the state has changed to disabled. Now, the one last command that we need to run is we need to go ahead and clear the crypto security association. So if I type clear crypto, whoops, make sure I'm doing that from the right. And let me make sure I'm doing that. Did I read that right? Whoops. Let's make sure I read that right. Clear crypto SA is executed. And let's go ahead and exit one level. So is it clear? I'm trying to remember here. Drawing a blank. Whoops. All right, so it's from privilege exec mode. So clear crypto SA, right? And this is going to clear all crypto SAs. And as soon as I run this command, what's going to happen is we're going to see that our neighbor relationships have immediately come back up. So 4 now has a neighbor relationship, and the encryption and authentication between those routers was already configured. So if I do a show IPv6 OSPF neighbor, you can see, you can see that now the adjacencies are now back to full. So let's take a look here on router 5. Let's do a show crypto IPSec SA, right? And so this is what we should see, where we have packets coming, it being encapped and decapped, right? Encapsulated, decapsulated, that are running between the different security associations. So you can see here, inbound ESP security association, right? It shows that we're running triple DES in our transform set. And what else can we see? You can see the SPI, right? The security parameter index for the inbound connection. So here's our outbound connection for 6.5 between routers 5 and 6. Again, it shows 6.5.6.5. Here's the transform set. So it's nice that you can actually enable this with a single command on each side and not have to generate IPSec config information like you normally have to do if you were doing like throwing IPSec on top of a GRE tunnel or something like that. So let's see what other information we have here. And so this guy's going to have inbound and outbound for the connections between 5 and 4. And let's look at router 4 here. So we can do the same thing. So we can do a, how about a show crypto ISACamp SA? Show crypto ISACamp SA, is that not right? Oh, yeah, interface config mode. Show crypto ISACamp SA. Don't forget the do. All right. So as you can see, we don't have anything. There's nothing set up with ISACamp, right? So with the OSPFv3, we're simply bypassing this, so to speak, in the sense that it's simply that connection between those two routers where we have the IPSec security association established. So one of the last ones we'll take a look at will be a do show IPv6 OSPF interface, and this will show us our interfaces where we have the OSPFv3 running, and there's the serial link between 4 and 5, right? And so at this point we've been able to set up OSPFv3 authentication, right, where we're simply doing an integrity check on the IP on the outside of the authentication header setup. We've set it up with encapsulating security payload so that we can do authentication and encryption, and we've been able to do that. Do show run int fa00 show runt. All right, so this right here was our setup for authentication, right? So this is just straight up authentication. If I were to do the do show crypto IPSec SA, you can see that it's clearly authentication header, right? Because we see our inbound and our outbound, and it's listed under authentication header for the relationship between router 6 and router 4, right? So if this was using the ESP header information, and I'll come over to router 5, you would see where it would show the inbound and outbound ESP. You can see for inbound and outbound authentication header, we have nothing, right? And so that's a really quick way to tell, hey, am I doing just authentication with authentication header, or am I doing more than that, right? And you can clearly see that when we've got ESP triple DES, that we are definitely doing encryption between these two. And so this is a great way with OSPFv3 and leveraging the sort of the built-in IPSec that's part of IPv6 to secure the OSPFv3 communications between your routers. All right, so that kind of wraps up this tutorial, and I hope that you know a little bit more about OSPFv3 and specifically how to leverage IPSec. You can go authentication header, or you can go ESP if you want to get encryption and authentication, which is probably preferred. And I also, again, want to repeat quick thanks to Jeremy Stretch at packetlife.net, who was kind enough to post up the code right here to generate, and if I didn't have any cut and paste woes going on right now, we could simply just cut and paste that and add that into our config to get a truly random 40 hex character. I apologize earlier, I kept saying bit, but 40 hex character string to use. All right, thanks for watching. I hope you found this video helpful in either your studies or in your day-to-day role, and have a great weekend.